to the following material perceptor with two hidden layers. All nodes use step activation function output plus one if total input is more than bias. Outcome if total input is less than bias. Y1 or 4 bias is indicated inside the node. Okay.
Uh,
Yep. Please increase. Thank you. So bias is 1,
so what
right?
will be the output y if x1 comma x2 is 2 comma 3? This is the first question. And again x1 comma x2 is 6 comma 4, 6 comma 3. And the third question is x1 comma x2 4 comma 3. So you know how to do this?
Okay. So x1 is 2,
Hmm.
and if x1 is 2, then uh, in every output x1 2, then if a total input is more than equal to bias, so
Okay, I
definitely
will.
it's more than equal to bias, right?
Yeah, because
So
this
2 will
2
uh,
into this is 2, right? x1 is 2, so 2 into 1 is 2. Then this is 0, so no need to think about this. This 2 is greater than 1, so this output will be plus 1.
what is 0? What is this 0? This is weights, right?
Weight
Okay,
of
these are
x2,
weights.
yeah.
Hmm.
So that we
Okay.
can ignore because any weight here multiplied by 0 is like 0 only.
Mm-hmm.
So we can think of if to drop out we can do this one also make the weight 0. No, the dropout is different, but to ignore this x2 input to this one we can put it 0. That's one option we have.
Mm-hmm. Now this second node,
Yeah, then this one, yeah.
so here
Again
x1 is 2
2,
again.
yeah, 2 into 1.
So it will give you -1. Just go on the top. Just go to the top. Let me see the question once again. Let me, if output school, if total input is less than bias.
So it's already mentioned. I put it the copy here, no?
Okay, okay,
Yeah,
okay.
this for
Okay, I put
hi
bias.
Pravina came here.
Hello, Pravina. So, so x1 here now input is 2, 3, right? So it lessens and -1 will go.
Yeah,
Okay,
yes.
okay,
It will be
and
-1. N2 is -1, yeah.
yes, x2 0 and then x2 1. It will be 1. Node
This
number
is
3.
3, 3 into 1, yeah, it should be 1, yeah. And 3 is plus 1, yes.
Okay, and 4 is again 1. No, no, it's -1. -1.
Yes, and power is -1, yes.
And 5 is -1.
Yeah,
And 6 is also -1. ठीक है.
yes.
Okay. Then what is the
Uh,
question?
Pravina, are you there? Okay, maybe she's not there. Okay, so the next one will be then same. Here also the same thing is affecting. I mean, this is the same. Uh, Bias at each node is indicated. Is all nodes use this step actor. So all nodes are having the same thing.
Hmm.
So then we have. I put it the screenshot
1
again.
minus 1, 1 minus 1, minus 1, minus 1.
One,
1
one.
minus 1. 1 and 3 are +1. Everything else is -1. Okay.
Yeah.
ठीक है. Okay.
So
1. So it is -1. Uh, and -1 into 1. Okay. That is also -1. First is -1, second one is -1. Now 1 minus 1, 1 into 2 and 4, which is -1. So it is 1. Okay. 1 minus 1 and
so which one you are doing? N7 or N8 or what?
total input to N7. Okay. Total input to 7 W13 and minus 1 minus 1 minus 1 minus 1. Mm, -1. Okay, there are 4 only, na? Okay.
So 4 is equal to 4, so its output is 1.
Hmm.
So here N8 is 1 or -1?
Okay, 4 output is has to be +1. Okay. Total input to N8 and 8 is +1. Everything else is minus. Okay. Everything else is minus +1. Everything else is minus +1. This is 1 plus 1, 2, 3. 3 minus 1, 2. 2. Yes, that is also -1. That
So
is plus 1 and -1. Okay.
plus 1 and -1. So this input goes here. So plus 1
Hmm.
and -1 becomes what?
0.
Yeah. So 0 is less than 1.
Hmm. It's -1. ठीक है.
Less than 1, right?
Hmm.
Output is -1. Yeah.
Hmm.
Similarly, you have to do this one for 6 by 6 comma 3,
Hmm.
right? So we got this answer. Again, I got it as -1. You want to do this?
If you've done this, it's fine.
Uh, Manoj, one doubt. We were discussing, right? Are these 3, 2, 4, 5, 6, and all that? These are the node numbers?
These are biases.
Oh, okay. So bias is not considered. So
This
the
is
weight is this.
this is a question. Okay. This is a question. So Satish, you know this one? Have you came across this question?
Hi Manoj.
Yeah.
No, no Manoj, no.
Okay. So Pravina, you know how to do this or?
No, I'm just trying to understand from what you people are discussing how
Yeah,
this can be done.
actually we told several times hi to you. You didn't answer actually.
Okay, okay.
Okay, that's fine. Yeah, no problem. So Praveen and Satish, maybe Vinay, you would like to take it once again, one
Ha,
before.
ha.
Yeah.
Okay.
Sorry.
So input is x1 and x2 at the bottom. Okay.
So they have mentioned x1 and s2 as 2 comma 3, and then we have to take as 6 comma 3, and then we have to take as 4 comma. So first we are solving for 2 comma 3.
So
So
guys, if Manoj, if it is okay, can all of us, either use our Excel or something,
mhm.
okay, or use notepad or something, okay? Just open that
No,
and let's do it together.
then you do it. Yeah, I don't want to do. I have already solved it here, so I don't want to
Ah,
do it again.
ah. No, everyone, if people are sort
Maybe
of,
Pravina is interested or Satish is interested, you can do it on the notepad if you want, or on the Excel.
I will open my Excel and as you
Okay.
explain, I will click here.
Yeah, you take a screenshot of this and put in the Excel and solve it then.
Okay,
we have
definitely.
not uploaded it in the Google Drive, na, this one?
Yeah, all the question papers are available, no, in the old repo.
Google
Yeah.
Drive.
But I am preparing a blog. Maybe in next 1 week before the session start, I will be able to. I have some doubts in the JavaScript.
Okay, which technology are you using to develop the blog?
Normal HTML, JavaScript, CSS only. No, you know something?
No, I don't know, but I want to develop my own blog. That's why I was asking.
Just go to the blogger, Google Blogger or the WordPress or
Yeah, I
GitHub
don't want to
pages.
use WordPress. That is why I've bought my site, but I don't want to use WordPress. So if you are using something like Java and or JavaScript or something, then I will look into that code. Anyways, we'll don't deviate the topic. Let us do this.
Yeah, so start with x1, x2. Okay. So just remember this thing that output is +1 if total input is more than equal to bias. Okay. So you look at the first node in the left. What is the weight in the first node in the left, in the first layer, first hidden layer?
One.
1.
1, right?
Yeah.
Now, and what inputs are going here? X1 and X2 both are going there. Okay. And their
Mm-hmm.
weight is 1 and 0, right? So X1 will get multiplied with its weight, plus X2 will get multiplied with its weight. Okay.
Okay.
And so it is 2 and 3. So 2 into 1, 2. 3 into 0, 0. So the sum will be 2. And when 2 goes here in the node 1, it is more than its bias, which is 1, right?
Okay.
Now, since it is more than its bias, then its output will be how much? 1 or minus 1?
If total input is greater than or equal to the bias, then it will be plus one. But this is
Plus 1, right?
total input is greater than or equal to the bias. Bias is one. Total input is greater. Yeah. So it will be plus one.
Uh-huh. Okay. So if you do all the calculation for all the 1, 2, 3, 4, 5, 6, there are 6 nodes here, and
Mm-hmm.
in the first hidden layer, and you will see the answer is the output of all these nodes is 1 minus 1 1 minus 1 minus 1 minus 1. Okay,
Okay. Got it.
got it. And next to the next step, similarly, 1 minus 1 1 minus 1, right? This is, you will see it is 4, so it will goes there. Out The input is 4, it is more than equal to the bias. So output of second hidden layer first node will again be 1, and output of second node of second hidden layer will be minus 1, because it is going to be less than. Okay.
Okay.
So total input to last node of the last output layer, the input is 1 minus 1, and it will be 0, and the bias is 1, which is so input is less than the bias, hence the output will be minus 1.
Okay.
Okay, so we did it for 2 3. For 6 3, just show the calculation, Manoj. We will see if your calculation is fine, otherwise we'll just leave. It is 6 3. Okay. 6 3 1 1 1 minus 1 plus 1. Hmm. Plus 1 plus 1 plus 1 minus 1 minus. Okay. So answer is
So
what is the answer?
this is up to n1 to n6 we got here. Then input to n7 minus 1. Then n8 is plus 1. So
Hmm.
output is minus 1.
Hmm.
So
Similarly for third also.
yeah,
Hmm.
4 comma 3 we have again the same calculations. So this calculation is understood, everyone?
Yes, I will just, after it I will just have a look at it. I have not seen second question.
You have
So
not seen question. Means what?
I
Question
mean,
is
I just looked at the first question, your first.
no.
Uh,
This is the second
uh,
question. Yeah.
this is in the sense that I did not look at it earlier.
Hmm.
Now only I'm seeing it. So I will check the calculation.
Okay, you can check it. Yeah.
Yeah. I'll check.
And maybe Pravina will also check it, right?
Yeah.
Yes.
Also.
Satish, are you able to get it something, or you don't want to do now, or yeah?
Yeah, yeah, I am just observing, so maybe I'll do it, Manoj.
You got it. The I mean the principle how to do it.
Yeah, I got it. I got it.
Okay,
So
nice,
only
nice.
one thing is like
Yeah.
I didn't see any bias 6, but I
Bias
like
six, second one, this one.
yeah,
Let me check
yeah.
why it's not
In,
there.
in
Yes, six. Yeah, six here is no. The X1 is six. Yes. This 1 into 6, yeah. Why?
Okay, in the diagram there is no bias 6, right? So only input is 6.
Yeah, yeah, they are asking the input is bias is fixed there. So they have asked x1 and x2.
Satish, you are right. There is no number six. You are right.
Yeah,
Don't,
yeah.
yeah. One, two,
So
three, four, five, six is not there.
1, 3, 2, 4, 5. Yeah, 1, 2, 3 is not there. 1, 3, 2 is there. And this bias is
yeah, so
different than, yeah, yeah, right, right, yeah. This is
so I see some calculations comparing bias 6 less than 7.
let me see
But
where is it.
That is because that is x1 value is six.
Yeah, x1 is 6, yeah. This one is what you're saying.
no, no, in
Last
total
one.
number
Yeah, last one.
n6 n6.
And 6 is
So
bias is 7, yeah.
but how come
Bias
bias
6 is 7, yeah,
is
see. Bias is 7.
bias is
oh,
7, but value of x1 is 6.
Yeah.
okay? So input we have changed it in the second.
Yeah, input is what they have mentioned as three inputs, no? So, yeah, have x1, x2, as 2 comma 3 and 6 comma 3 and 4 comma 3. Three inputs we are giving separately. We need to find the outputs. And
Okay, okay,
university has given the answer as minus 1, minus 1, minus 1. Yes, we go to the same answer here.
okay, okay, okay. I got it. Yeah,
Got
thank
it? Yeah, okay, fine. Yeah. Now let's go to the B part. The B part they are saying following multiple B. Express output Y as a decision rule of input x comma x1 comma x2. Recall decision rule is expressed as an if else then statement. Y is equal to x1 greater than 2 or x2 greater than 7 and x1 plus s2 is equal to 7. So like this we need to express the Y.
Hmm.
Okay. So let's see again one how we can do. Let y be assumed as plus 1. Now we are taking a y, we are assuming y, we have to come back from y, no, we have to come back from y and find the x1 and x2. So when we take it as plus 1, then what will be the inputs? That's the question. N7 and N8, right? These two are fixed, 1 and 1. So what should be the N7 to make this one and what should be N8 to make this one? So this is added, right? So
Yes.
given
Either
output,
both of the output from just look at the diagram once again. Na? Yeah, N7
For
and 8
plus
uh,
1, we need bias
or
input should be greater than or equal to bias. Like,
N7 or N8 is equal to 1. N7 is equal to 1 or N8 is equal to 1.
or both, right?
So or means both, or includes both.
they have either minus 1 or plus 1. Okay. So N8 can be either plus 1 or minus 1. So
Ah,
if you see, if 1 is minus 1, this will be 1. 1 plus minus 1 will be 0. Then this will output will be minus.
Minus 1.
Yeah. So we will not get that output. Only when these two are 1, when output
ah,
of N7 and N8 are 1, only then the output of
we were thinking of it as a 0, but that is not 0, it is minus 1,
yeah, so
right?
here I have written it given output plus 1 if the total input is greater than bias. Here bias is 1. Hence
Mhm.
input has to be greater than 1. Input is given by n7 into out n7
Correct.
out into 1
Correct.
plus n8 into n8 out into 1. This to 1. Okay.
You thought about it yourself, Manoj, or someone
No, I told
helped
you
it?
no, I am taking a tuition from some data scientist
Acha.
to solve these questions,
Uh,
and I am sharing this with you so that it will be concrete for you and it will be helpful for you. I mean, concrete
us.
for me and helpful for you. Yeah. Mm.
Oh, great, great.
Good.
This guy is good. Hmm.
Yeah, yeah. So it's easy. No?
And who is your, where is your tutor based in?
He
India?
is from yeah Bangalore ISRO. He is at ISRO and data scientist. Yeah.
Ah, okay.
Mm. Yeah, he's a young chap. Yeah.
How did you find it?
From teacher on.
Teacher on.
Yeah,
Okay.
this one website. Yeah. I advertised there. So many people came, and this guy seems good. Yeah. Okay. So
Should have got this idea last semester itself.
sorry, what?
Last semester itself, if you had had this idea, it would have been really good.
Yeah, yeah. Even from the sermon, I am doing this. But what happened is, I am looking for cheap ones. You know, these guys who are coming are very costly. I cannot afford because I have less understanding of these things. So I will have to take several hours, and it will be very costly for me. So
Okay.
this guy is like a compromise. He is always saying that amount is less, but then still he is very enthusiastic about answering the question. He is very happy to have this difficult questions.
Okay.
Some people, no, they will say they will solve, and once they see the question, they will run away. This happens several times. So even in
So
the center,
he solves it in front whenever as soon as you give him the question, or he looks at the question paper and comes back.
no, no, he takes his own time and looks on it and comes back. Yeah.
Okay. Then we cannot have them as standby during exams.
Standby, yeah, standby during exam. That's a good. Yeah, to
He's
avoid
really
that, I am learning this deal. At least if I get 55 by studies, no, that will be nice.
Mhm. Okay.
go ahead, go ahead. Yes,
Yeah.
it is
So,
correct.
yeah,
Both N7 and output have to be +1. Okay.
exactly. Yeah.
Uh,
So then we are going to the next level. So here, N7 and N8. What should be the output? This should be output of the N7 and N8 should be 1. So for
uh,
N7 to be 1, we should have here uh, 4. No, you
The
should get at
total
least
should be
4, right?
greater than 4.
1 minus 1, 1 minus 1.
Yeah, so the
It's
output
be
has to
greater
be
than
1
or equal
minus
to
1,
4.
1 minus 1. Yeah. Same like bias, we need the output. I mean, the same like this weight, we need output. Like 1 into 1 will be 1 plus minus 1 into minus 1 will be 1. So 1 plus 1 again like this. So it will be, we need the same like that outputs. Okay.
1 minus 1, 1 minus 1. Okay.
Yeah, so it has to be in 1, has to be, yeah, this is where I mentioned, yeah.
It should be
1
4 or
minus
greater
1, 1
than
minus
4.
1, yeah.
That,
Okay.
So similarly for N8 also we need a similar N 1 is 1, 1 minus 1, 1 minus 1.
Mm-hmm.
And this, yeah, N's 8 is not connected. Okay, okay. This one I can remove here, yeah. N3 starts from N3, na?
Mm-hmm.
It comes from N3, not from
yeah.
N1, N2, yeah.
3, 4, 5, 6.
Yes.
Sorry, 5, 7.
So
3,
this
4, 5,
answer
7.
actually, he didn't give these steps actually. I wrote it myself, so there can be a mistake, so you can check it out here. I'll share the document, you can verify yours, or you can answer it by your own and verify this correct or not.
Please share and
So basically, I have one question, Manoj.
Yeah,
So so when we do backward propagation, so we will be adjusting the weight, right? So why are we?
actually here we are not doing backward propagation. We are just trying to find what should be the values of x1 and x2 to get the output y as plus 1. We are
Okay,
not doing a backward propagation actually.
okay. So then, what are we trying here? Then,
We are trying to
uh,
find what will be the values of what is the values of x1 and x2 under these conditions. What should be the values of x1 and x2 to get a plus 1 in the output? Because we took assumed a plus 1 as output, and we are going, see, the question is, see, express the output y as a decision rule of the input. This is the question.
okay,
You need to find some values of x1 and x2 that will give you the expected y,
okay.
right? So I am yeah, I am assuming it as plus 1, output as plus 1, and I am trying to find values of x1 and x2 which will give me plus 1 in the output,
Okay.
and after that we will find for minus 1. So that's the strategy.
Okay. So the number in between nodes or weights, right?
Yeah, this is the
One,
weights
zero,
and this is the no, biases. Yeah,
biases.
this is bias, this is bias, but this bias is not actually the normal bias we use, no, in the adding of the line, that stuff, no. Here the rule is they have already mentioned output is plus 1 if the input is greater than the bias. So we are not adding the bias or something going. This is the rule here in this diagram.
Okay.
Yeah,
Okay. Thanks, Mo.
yeah, fine.
And we will multiply all the weights.
Yeah, we have to multiply the weights with the inputs. Yeah, as usual. Yeah.
and sum it up.
and yeah, and sum it up and check whether we are not adding the bias. We are just verifying it, comparing with the bias, and whether this rule is
Satisfied.
yeah,
Okay.
satisfied. Yes.
Okay. Okay. Okay.
Okay. So we got for n1, n2. This one we got. So it is interesting to know that n1, n2, n5, and n6 are dependent on x1. So if you see x1, this n1 is not dependent on n2, x2 because it's 0 here. Similarly, n2 is also not dependent on x2 because it's 0. N3 is not dependent on x1 but it's dependent on x2, and n4 on x2, and n5 on x1, n6 on x1. These are not dependent on x2. So yeah, so here is the strategy. Like if x1 is greater than 1, then n1 is 1, right? If x1 is greater than 1, so how to make this one 1? See, our requirement here is already mentioned, no? So output has to be this. We already found, no?
Mm-hmm.
Right? We already got this one because only with this one we can have an output in the n7 as 4, no?
Mm-hmm.
Similarly, for n8 to be 4, only when it's 4, then you will get a 1.
Mm-hmm.
So these two requirement has to be satisfied. For this to be there, then this should be n1 should be output 1 and n2 should be minus 2. So n1 is plus 1 means this the input should be more than or equal to this 1, no?
Mm-hmm.
So x1 has to be equal to 1 or more than 1, right?
Yeah. So I did a calculation. So to match the next node, which is 3, it has to be less than 2. I mean, sorry, less than 3. Then 5 and 7 will not, 5 will go for a
This
toss.
has to be
So
less than 2, right?
yeah,
X1 has to be
less than 3.
less than 3. That is 2.
Yeah,
2 or equal to 2.
correct.
Yeah.
2 or 1. It can only
Yeah,
be
it
1
can
or
be less than or equal to 2. Yeah, right. Exactly, right. Yeah. That's what I mentioned here. Less than 3 means it has to be equal to or less than 2.
less than 2.
Yeah, okay.
Right? So, but then N5 will go for a toss because it has to be minus 1, but 2 is
It has to be
bias is
minus
3.
1. Why? It should be, output should be 1. Yeah, and 5, no?
Yeah. Sorry, 7. Sorry, N7.
Mm-hmm.
Okay, you have named it as N6, correct. So, because you need it as minus 1, right?
Mm.
So, input should be less than bias.
Yeah.
Yeah, it will come, right?
So this is what we finally found. Vinay, are you able to get this one?
Yes, yes, yes.
Yeah, you got this one. This is important part. Okay,
Mm-hmm.
how to get this conditions of the x where you satisfy these all these nodes. Okay, so one you got, no? This one should be one. Then n2 should be what? If n2,
No, for N5, X1 has to be greater than or equal to 5, right?
yeah, we will
Can
go
you put
from
can you put it in the chat box link for this?
yeah, sure,
Uh, I will look at it at at a slow pace so that because now
sure.
what is happening is
Mm.
it's moving fast, right, up and down. So
You want to check it now itself or later?
Actually,
uh,
because
it's
when
your
you said
wish.
I took a screenshot, so I'm able to look at both of it together.
Yeah,
Might be
screenshot. Yeah, you can take the screenshot also.
so that is why I'm doing the calculation in parallel. Sorry.
Okay, I will put the screenshot so maybe Vinay can.
No need to. I am not accessing it. I'm just looking at it. It gives view access, right? I am not asking you for so I can access it now. Yes, it's not a problem. Now I will look.
Okay, okay. So just tell me or Satish if you understand this part or not. Yeah, this is the important part. Um, I will put
I
it.
got
Yeah, you got it. I know you got it. Okay, I am looking for Satish and Vinay. Yeah. So
there's no one
Satish,
like
actually I put it in the chat. Can you check it?
Yeah, sure, Manoj. Yeah,
You are able to
I'll
check
do
it,
that.
no? Yeah. No, no, not later. Now we can do or not?
Yeah, I'll do it after some time. Yeah.
Oh, okay.
So you will have to explain it once again, Manoj, later.
Later, no, no, he will do it, but I was expecting him to do it now. I don't know why later. Vinay, you can do it now?
You see something else.
Yes, I'm looking at it.
Yeah, yeah.
Satish, you want us to explain it once more?
Yeah, Pravina, if you can explain it, maybe he will understand now.
Okay. So do we start from the Y portion or only the N1 and 2? Okay. So Satish, what Manoj has done is for this question, we need to prove. What was the proof which we had to do, Manoj? Can you go to the question? Let us read the question.
Express the output y.
Y as a decision rule
Yeah.
of input x1 and x2. Okay, so we have to actually find a rule based on which we can express the output of y. That is, so we have to actually express it starting from x1, x2 only. But to do that, what has been done is in this exercise, we start by assuming that y will be 1, right? If the output, final output y is 1, then how do we backtrack it all the way to x1 and x2? And that is what, by using all the rules which is given. So the rules which are given is output is +1 if the input to that particular node is greater than the bias which is mentioned at that node, right? And output is -1 if the input to that particular node is less than the bias. Now, yeah, Manoj, you can enlarge the diagram. Correct. Okay, so now assuming that this y is 1, we get this as 1 based on the rules, right? Our rule says that if the input to this is greater than 1, then the output y will be 1 because the bias 1, it has to, the input to this particular node has to be either 1 or greater than 1. And how will this become 1 or greater than 1? It is I mean, n7 should be 1 and n7 is 1 and n8 is 1. Only then the output of this particular thing, right, from n7 to y will be 1 because 1 into 1 is 1 and 1 into 1 will be 1. So total is 2. If this n7 was 1 and n8 is -1 or vice versa, this would have become 0, which means the bias is less than 1 and therefore it will not be +1. So we assume, based on the assumption that y is 1, we assume that n7 and n8 are both 1. Now, for n7 to become 1, what are the inputs to n7? We see that in this diagram, n1, n2, n3, and n4 are connected to n7. So now for n7 to be 1, the total input to n7 should be greater than or equal to 4. How can 1 minus 1, 1 and 1 become 4 or 4? Only if n1 plus 1, which is 1 into 1, n2 has to be -1 because if you see this, there are only 4 nodes and it's alternating 1, -1, 1 and -1. So for this to be equal to 4, I mean, at the max, we can make it equal to 4 because n1, n2, n3, and n4 can take values of 1 or -1, right? So 1 into 1 will be 1 plus 1, -1 into -1 will be again 1. 1 into 1 will be 1 and 1 into -1 will be 1. So if n1 was 1, n2 is -1, n3 is 1, and n4 is -1, then the total with input to n7 would be 4. And therefore n7 can be 1 as the based on the output rule, right? So that is the reason why now the assumption makes us n1 is equal to 1, n2 is equal to -1, n3 equal to 1 and n4 is -1. Similarly, we can do from for n8 also, which is N8 is connected to N3, N4, N5, and N6 in this case, right? So which calculation will give this one? Only if the total to this N8 is again greater than or equal to 4. And again, we cannot have anything more than 4 because all of this is 1 or minus 1 calculation, right? So based on that, we find what should be the value of N3, N4, N5, and N6. Now, what we are looking at is on a similar basis, we look at x1 and x2. But x1 and x2 can take any value, right? It is not limited to 1 or minus 1. So now what we are looking at is for n1 to become 1, again the output rule, the input to n1 should be 1 or greater than 1. But n2 to be minus 1, we need the input to n2 to be less than 3. Now from x2 is connected to n5, right? So Satish, you're able to understand?
Yes, Pravina, yes.
Okay.
But
now
in
for
the first N7, N8 itself, right? So rather than putting 1, comma 1, if you put 2 also, it will be greater than.
No, you can't, right? Because there is in the question in the beginning, if you notice over here itself, it is there, right? The second line, if you see in the document, it says given. Manoj, I think you have moved the mouse.
What happened?
So it's already given that the output is output from a particular layer. So if you start from x1, right? See, x1 and x2 can take any values, but there is a in the question it is given output will be +1 or -1. Okay, so it's a given output of any transformation can only take a +1 or -1. It cannot, therefore, any of the hidden nodes will not take any value other than a +1 or a -1. Only x1 and x2 can take any values. After that, any other node which is hidden, because it is given that the output can be a +1 or a -1, we based on the bias value, those nodes are not going to take any value greater than 1 or any value less than -1 or a 0. You got that?
Yeah, now it makes sense. Yeah.
Okay, so the hidden layers will not take any value. Only x1 and x2 can take any value. The rest of the nodes, because of that given condition that the output is 1 if the input to that particular node is greater than or equal to the bias, and output is -1 if the input to that node is less than the bias. So because of that condition, that N1, N2, N3, N4, N5, N6, N7, N8, and also that Y will only take a +1 or a -1.
Okay.
So based on this, we go all the way back, and when we reach x1, we see this particular condition. So I already explained for x1, for n1 and n2. For n5, what will happen is, because the bias is 5 and we need a +1 over there, right? So if you see that to get a +1, we need a value of x1 which is greater than or equal to 5, right? And that will violate the condition that n2 can only be less than or equal to 2. So when this condition is violated, we know that output of y cannot be 1, because if any of the when we are considering the output to be 1, this condition is already violated. So now we say that whatever we do, we can only get the output of y as -1.
Okay.
Got it? So that is what is being proved over here.
So here it mentions the values of x1. It has to be greater than 1 for n1 to be 1, less than 2 for n2 to be minus 1, and it has to be greater than 5 to be n5 to be 1, less than 6 to be n6 to be minus 1. If you see, these two are middle two, these two are controversial, no, it's not compatible. X1 should be less
They are
than 2.
conflicting each other.
Yeah, they are
So if one
conflicting.
says it has to be less than 2, I mean, x1 cannot at the same time be less than 2 and greater than 5, right? So it's a conflict. And therefore, considering that y will be 1 is not possible.
Y will be always minus 1. And this is for x1. X2 you can take it as uh, greater than 2 and less than 3. So this is realizable. Else 2 can be this 2 or 3, but x1 cannot be made practical. So answer is, if x1 is less than or equal to 2 and also x1 is greater than or equal to 5, this condition, no, it has to be less than 2 and greater than 5. So this is not possible. And x2 has to be 2 or 3, that is possible. And output, then the output will be plus 1. These conditions are not practical, hence output is always minus 1.
So similarly, like how we did for x1, you can do for x2 also. But yeah, it's not necessary as such. When we do x1 itself, we know that it's not possible, so we'll have to go for the condition of -1 and see.
x2 is done here, no?
Yeah, no, I'm saying if we okay, during exams, if we find that we don't
It's
have enough
irrelevant.
time,
Yeah, it's irrelevant. Yeah.
during exams we sometimes we might run out of time, right? So when we get to this thing, we can actually do a conclusion and say because of this, you kind of thing, right? So we don't have to spend that
Yeah, right,
additional
right.
time.
Yeah. Just for our understanding, we have written it here in this way.
Right. So generally during exams, if we understand know something, we'll sit and write that, and we'll forget that we have to answer. This time in ML, there was a question which was already there in one of the papers. I didn't attempt that because I never reached that question.
Okay, so Satish, you're comfortable with this?
Yes, Manoj, I got that concept.
Yeah.
Yeah, maybe I'll work it out.
Okay. And Sudeep, you know about this?
I
Sudeep,
know, actually, I joined a little later. Actually, one thing I did not hear. I am hearing. Maybe one more time I have to go through. After the session, maybe you can share this answer sheet also. I will go through. Then next time I can ask you.
yeah, it's already shared. I think in the chat. Can you see in the chat? Yes, I already shared this.
Understood.
First, you have to go through this one, A part. It is. Then you can go through this B part.
Ah,
Yeah.
I'll go through. Then I'll see.
Anyone want to tell Sudeep how this one? Maybe Satish want to tell how this works?
So Satish can explain.
Yeah.
Yeah.
You can give him a punishment
Yeah. So the question here is that we have
One,
got the
one.
answer.
Okay, sorry. One. So Manoj, we are going to discuss only this question today, right?
now. Two
Yeah.
questions
Yeah.
we already one A and B. Yeah, I think that is
Oh,
maybe one more
okay.
is there. You want to discuss this? C.
C is.
Yeah.
Hold on.
Hmm? I think it's better to discuss the same thing and make it concrete and see if you have time you can discuss C. It's not much there in the C. Yeah. Just a small thing is there.
What is the question in C?
Yes, C is, can this distant rule be realized through multi-layer perceptron with single hidden layer? If true, yes, Y, yes, and all. So answer is, see, output is always Y, no? I mean minus 1. So do you need so many
-1
hidden
here.
layers and all these things for getting the minus 1 always?
No.
Yeah, so that's university solution. One hidden layer will be sufficient since output is always minus 1, irrespective of the input. Whatever input you give, output will be minus 1. And even one hidden node is enough. No actually
Correct.
hidden layer is required. That's what they said.
Because what even x1 and x2 is not required actually.
No, no, input is required. Input is required, but why it is showing that no hidden layer is required? 1 0.
See, whatever be the input, the output is -1,
Ah,
right?
where is the link for this? Can you just put the link for
Yeah,
this
yeah, I
also? I'll
will.
just
I will share the folder link so you can go through all the.
So if the
Just
bias
the
will be very
C
high,
C question C 2C. I will just have a look at it now. Why the Pandey? Actually, for B also, whatever your tutor has written and whatever you have written,
Mm-hmm.
I got lost in whatever you had written. So I looked at what he had written,
Ah,
and his concise thing I could understand.
okay.
Probably because mathematics.
Yeah, so yeah, that's the difference. No, I am writing it for my understanding. Yeah.
Ah, okay.
Mm.
Okay, go ahead, guys.
So C is only this information that we can just put one hidden layer with the output of -1. That's it.
I'll
So
have looked at it.
yeah, so maybe Satish can explain this question A, right? This one, yeah. To Siddhi, yeah.
Okay, Sudeep, right? So okay, so here we are trying to, you know, we have got the output, but we are trying to understand what would have been the input to get that output. So
Yeah,
with
output is
set
the Y, yeah. Y is the output, yeah.
yes,
The X or X2 is the input, yeah.
yeah, that's right.
Our middle layer is 1, 3, 2, 4, 5, 7. Those of you, and the weight it is given. Okay,
Yeah,
tell.
those are the hidden layer, and 1, 3, 2, 4, 5, 7 are bias, and the other 1, 0, 1, 0 are weights.
Mm. Mm.
So the condition is like output equal to 1 if total input. So total input is nothing but x1 into weight, x2 into plus x2 into weight.
Mm.
Okay. So
Mm.
that's the total input.
Mm.
If it's greater than or equal to bias, then output is going to be +1. If total input is less than bias, then -1. Okay. So in first
Less
case,
than last statement you take. Greater than bias and less than bias. How you are doing that thing?
so total input is like input into
In
weights,
wait, okay.
right? Plus x2 into weight,
Mm.
That's
x1 into
the
weight.
standard formula, no? To
Mm.
yeah.
Bias plus bias.
No, bias here it's different. They have given here this statement, no? So we should know we should use this bias only to compare the input total
Okay.
inputs. Yeah.
Okay.
So here they mention that bias at each node is indicated in less than
Mm. Yeah, yeah. If the input is total input less than total bias, then only the output will be -1. If
okay.
total input greater than equal to bias, then output will be +1.
Yes.
Okay, okay.
So, so let's assume we are giving input x1 2 and x2 3. Okay. So in that case, x1 into x1 is 2, 2 into 1. So we are multiplying input with weight. So 2 into 1, it's going to be 2. And then, so in that case, input is going to be 2. If you compare 2 with 1, it is 2 is greater than 1. So that's why we have got output from first node x1 output is 1. If you first x1 to n1.
Mm.
Clear, right? X1 to n1. Just a single line I'm trying to explain.
Mm.
X1 is to the very first left side node. X into 1,
Mm.
it's equal to 2. So 2, if you compare it with bias 1, so it is input is greater than bias.
Yeah.
So meaning, so output is going to be one.
One.
So that's why we from N1
Mm.
node, the outlet line is
Yeah, yeah, understood.
having x1 with second node n2. X1 is 2, 2 into 1, 2. So if you compare with bias, so input is less than bias. That's why the output line is going -1.
For each path, actually, they are creating separate output. Then finally,
Yeah,
all
yeah.
output they are doing sum up or what? Finally, final come down below slowly. No, for each after that at the end what they are doing for up to N6 they calculated. Okay, after that N1 1 in exactly just keep it there, keep it there. 1 into this thing. Okay, the total input to N7. N7 and N8. Oh, then it goes to N7. Again, they are doing that calculation. Total input to N8. Okay, total input to N9. Okay, so I think that's okay. Understood this. Okay. Hmm.
Okay. Likewise, uh, so if you go from N1 to N7, um, N7, N1 is we got N1 as 1. So 1 into 1, it's going to be 1. So if you compare it with bias 4, it's
Hmm.
less than by, oh, no, less than total input. Okay, it's going to be total input. So we have to sum up everything. So in first case, it's going to be 1 into 1, 1. In second case, it's going to be, okay, -1, -1 into, okay, so whatever we are, Manoj, whatever we are giving, when in the N2, what's going to be input in this case?
N2.
Yeah, from 3 node, N2, it's going to be -1.
Yeah.
Okay,
For 2
okay,
by
okay.
3 question, right? 2 and 3 question, no? Like 2 comma 3. X1 is 2.
Yeah, 2 comma 3, correct. So N2 is -1. So -1 into -1, it's going to be +1.
I have put it here for convenience.
Okay, okay, okay. Perfect then. Yeah, that's what. N2 is -1. -1 into -1, it's going to be +1. And first case, 1, 1. And in third entry, it's going to be 1 into 1, 1. And then fourth case, it's going to be -1. So overall, it's less than uh, 3, 3 comparatively 4. It's
Where
input,
exactly
total
you have to
input.
say? N7 or N8 or which one?
I'm just trying N7.
N7, okay.
N7 first is
One.
3 less than 2, 4, right?
Is it 3? It should be 4, right? 4 less than or equal to 4, no? Calculate once again then.
So
Yeah.
N1 is 1, 1
1.
into 1, 1.
Yeah.
So second case minus +1, -1 into -1,
Yeah.
+1.
Yeah.
And then third case, again +1,
Yeah.
it's 3.
Mm.
And fourth case, it's going to be, oh, N4 is -1. Okay, 4.
Yeah.
So 4 equal to 4.
Yes. So output is 1. Yeah.
Okay, output is 1. Okay, it's equal. I thought like N4 is +1. Okay, fine.
Mm.
Okay, so and so likewise, we're gonna calculate for
Just
N8.
calculate this one also. Yeah. Mm.
Okay, so N N2 is -1 into 1, -1, and then
N2 is
N4
not
is,
used. N2 is not used. N3 is
sorry, okay, N3 is +1 into plus 1, 1,
used. Mm.
and N4 is -1 into -1 +1, and then n5 is -1 into +1 -1, so total is 1, and then n6 is -1 into -1 +1, so 2. So 2 is less than 4.
Yeah, -1 is output.
But there we have added +1, right?
Where?
4 to 1. Okay, that's n8 is -1. Okay, not the output. Okay, n8 is -1. Correct, correct. Okay.
Yeah, so we have -1, then these two weights are there, no? -1, +1 into +1 and -1 into -1, yeah.
So n9. N9 we have to calculate. Okay, n9. Okay, okay, that's right. -1, so 0. So 1 is less than 0. So 0 is less than 1. So output is -1.
Yeah. So Sudeep, you got it?
Yeah, I understood the approach here.
Fine, fine. So that's about the A. This is question number A, no? And then when you are going to question number B, you
Hmm.
need to express this as a
Why as a decision rule
decision rule, yeah.
of input, recall decision rule is expressed as an if-else statement. Y equal to x1 greater than 2 or x2 less than 7 and x1 plus x2 equal to 7. For any other input output node is at most 0, so how it is represented? Uh,
So we have to find like what is the output y for a particular input. Yeah. So y can be either output is either +1 or -1. So we have to take
ah,
the both cases and calculate backwards. So now Satish will again explain this.
Okay. So if you consider +1 as output, then if you come back, so
Yeah, can you
it
share your
the
screen
bias.
and explain? I need 1 minute, right? Just go to
Yeah,
WhatsApp.
just leave that screen, Manoj. I'll explain it here itself.
Okay, okay, okay.
Okay, so here, right, so we have to consider first output as a +1. So if the output is +1, then the bias should be the in total input should be greater than or equal to bias.
hmm.
So in this case, so total output supposed to be total input supposed to be greater than 1. Okay, so in that case, uh, 1 into 1, it's going to be 1, and then can put n8 as a +1, so 1 into 1, 1, so it's going to be 2. So total input is greater than or equal to 1. So if you put n7 1 and n8 1, then it will satisfy. If you put n7 -1 and n8 +1, then the total input it's going to be 0. Then it will not get satisfied. Okay, so in that case, n7 is going to be 1, n8 is going to be 1. So if you come back again, so to have n7 1, n7 1, have we have to have n7 1, we have to have in total input supposed to be
N1, N2, N3, and N4, right? Because
yeah
N2, N3, and N4 are impacting N7.
yeah. So if n7 has to be 1, then sum of n1 n2 n3 n4 has to be greater than 4, right? Yes. So in that case, we have to assign 0, sorry, 1 or -1 uh,
N2, N1, N2, N3, N4 to have uh, total input as greater than 4, right? So in that case, we need to have N1 as 1 and then N2 as -1, so that we will get 2, and N3 as +1 and N4 as -1, so that at least it will become 4, so that the first condition will be equal bias, total input is equal to bias. Okay, so N1 is +1, N2 is -1, N3 is +1, N4 is -1. Okay, so if you come back to have N1 +1, we need to have uh, X1 as 1, so that okay. So here we have X2 as well for N1. So to sum up, X1 can be
X2 is
1.
0. It's 1, 0, 1, 0, right? So if we look at it from X1, N1, N2, N5, and N7. These are the ones which are having the weight of 1. And X2, it is N1, sorry, it is N3, N4, that's all, right, as the input. Because the weight is 1 only for N3 or N4. Yeah, you continue. I'm just wherever you're.
Okay. Thanks for correcting. Okay, so first, so we can skip 0 weight and then we can go with only 1 weight. Is it? That's what you're.
Yeah, because if it is 0, then
It will
whatever
become
the
0.
value, it will still be 0, right?
Yeah, that's right. So in that case,
That I will just explain for 1 or 2 minutes the C part. Okay.
Okay. Yeah.
If do you want to talk about the C part? Let other come, na?
Yeah.
Just make sure you do not leave any laptop in there.
They are not joining.
Yeah. Probably they. So the C is just saying that actually the question is, shall we talk about that?
Okay. Yeah. If they are joining, then we can talk here.
So do you want to talk about what is your understanding,
No,
or
I
you want me
already
to?
told you that I already told that y is equal to -1. Then we can realize it, but just one layer. No need of extensive.
So the question is, can it be done with one hidden layer? Yes, it can be done with one hidden layer. The and if it is one hidden layer, then how many neuron it needs? Nodes it need? So minimum. Yes, one hidden layer, one hidden node, right? At
Yeah.
the end, they have written that is university has said that actually nothing is required. That is also true. But if it can be represented by one hidden layer, yes. And in this hidden layer, what is the minimum number of node you require? One.
Yeah. So what is your understanding now? Anything new is there?
No, that's it.
Yeah.
Whatever.
So yeah, I already explained this one. No.
Uh,
Yeah.
yeah, very strict.
Yeah. I think they are not joining, so we can maybe stop it. No.
Ha,
Oh,
ha, ha.
Satish has joined. Okay.
But your tutor has very nicely. I really like the way because he's worked in an inequality way, and probably you think in more word sense. But he's written. I like that. Very nice.
That images, right?
That whatever he has written,
Hmm.
solved it mathematically very clearly. Okay.
I
So I
don't
think
understand.
how many questions are there in this?
5 questions, no?
Five questions. Okay. Okay, then we can finish this actually. We'll
Yeah,
finish
the
Yeah.
thing
this
is,
in.
when the tutor takes, no, I am paying for one question 200 or something. Yeah.
So we can all chip in actually. If everyone is interested, we
No
can
need,
pool
no
in.
need. I am happy with him actually. I am learning from him, so it's completely okay for me. Yeah, this is not a big
You get a
issue.
call. You discuss it on the call or something.
Yeah, yeah. There's a meet, but that's not regular. No, whenever he gets time, he tell me, and I just join that time. That's it.
Okay. Okay.
So currently it's okay. If more questions are there, we will see how it goes. Yeah. Currently I'm able
Mm,
to afford it. It's fine. No issues. But as you said, yeah, if there is more questions, then we can check it out. Yeah. We can
yes.
support sharing and all.
And on the electives, I was going through, graph and probabilistic graph. They look really nice if you want to get deep into what you were saying, no, in video and all those things.
Mm-hmm.
Probably they'll be a bit more mathematical,
Actually,
but
I am very bad in maths, so I think I should refrain from there. Otherwise, it will be. Otherwise, I have to take only maths. I mean, the graph only. Then it's okay. Now there's so many four subjects, no?
hmm,
Too much. Yeah. I don't know. I can.
okay, okay.
Manoj, you're awesome, awesome, Manoj. Like always,
Huh? What?
you know, you're you're so much interested to learn, but you're very down to the earth. You're always like if you don't know, just you're straight away saying that don't know. Right?
How is this chap Sumil? Does he help and all?
Yeah, Sumit is the one who is helping in the automation and all. No, he's a very intelligent guy. Oh my God, yeah.
Yeah.
Intelligent and
Because he's there
yeah.
in graph, no. So if he's in the graph, then
Yeah, yeah,
okay, I can.
yeah, yeah. Of course, yeah. But the thing is, we need to take interest and go ahead with asking questions and all. No, then he will help. Yeah,
Then
that's
I
the
will
problem. We need
anyways
to
will
take the
be.
initiative. Actually, yeah.
What?
We need to take the initiative to learn. No.
Hmm. Hmm. And where did you get all these questions?
Question two questions I got from question papers. I got from that old repo
Okay.
from Pratiksha. Then one I got it from online.
Okay.
And I
Manoj,
have
how are you managing your time and all, Manoj? Like you'd be having office also, right?
yeah, the thing is like Lord Krishna said in the Bhagavad Gita, no? So he's able to manage the whole world with this a small, what is it, amsham, no?
Yeah, yeah.
So in my office, I need only spend a small amsham of mine to work.
Okay, okay, that's good.
Yes, that's good if I make use of the rest of the time. Yeah. Mm. But the thing
Okay.
is, I need this combined study team, no? Then only I can improve. Yeah, that's why I'm pushing everyone to combined study. So Vinay, you and sometimes Pravina and Sudeep, they are coming, and sometimes Yogi is coming. No? So some people are there. So this combined study is really good for me actually.
Yeah, yeah, that's right.
So like,
Okay.
yeah.
Okay, guys.
Okay, guys. Yeah. Then tomorrow I hope somebody will be taking the session. Otherwise, I will be taking the next question. Yeah.
Okay, okay, sure.
Satish,
So
whenever you free, you can
have you
let us know when
completed
you
all the
want to
five
take.
Yeah,
questions? Is that what you're saying?
Uh, I'm saying if Satish is able to take tomorrow, no, I mean Veena and Vivek, they are not responding, so I think they are busy. So
okay. That's
tomorrow,
Manoj. Like even I was a bit of confused because last class itself I covered that practical part of it itself, practical stuffs as well. So Vinay also taking care of it. So that's why I don't know like what to take.
actually,
I can.
Satish, I sent you one R2 book and one other book, no, like practical Keras book. So this one of these
Yeah,
two
yeah.
books we can go through. I mean, we need to
Just
have a
follow
systematic
follow follow
study.
those
Yeah,
books.
Vinay is taking R1 actually.
Okay,
So you
okay.
can
So
either
I can
take
go with
R2
R.
or you can take the other practical that one Keras thing. Yeah, one of the book
Yeah.
yeah, one of the two books you can select which one is easy for you. No, because no,
Mm,
see the thing is we don't want to press people. No, so learn so much and come for this one. No, whatever you like, I mean, what is your comfort and what you think is valuable for you, you can do that one. And if you can share like
Yes.
45 minutes or something per week, that would be nice for you and for others also. If you think it's good for you, uh, do it. Otherwise, some people are there very intelligent and they don't want to say anything, like they want to don't want to share anything. Some people are also like that. I have come across.
Yeah,
Uh,
yeah. So in the slide, I have a couple of Keras code. Maybe I'll try to in the class itself we can try to use that. Like I'll because I had some notebook which I already explained, but so if you wanna do that with some other code, then maybe I'll go with the slide one. Like whatever I had it in the slides, we can just run it. Yeah, I'll check that R2 book as well. Like if I find anything which I can understand, then I'll share it.
yeah, it's a basic book actually, and always few pages are there, maybe 200 or 300 pages, I think we can,
Mm.
if you have a systematic study, then because this is recommended by university, so they have taken some good book. So if
Sure, sure.
yeah, so
I'll go
if
through
you
it.
take R2, then Vinay is already taking R1, and then
Mhm.
T1 is like our syllabus. So somebody will be taking, like Yogi is going through that, and our sessions will be going through that. University session is going through the T1 also.
Yeah,
So
that's right.
and
That's right.
yeah, so DL will be pretty well covered then, and I will be taking the questions, question answers.
Yeah,
So
yeah,
that way
yeah.
DL will be very
Maybe
nice.
I'll go through it. Then I'll let you know.
Yeah, yeah. You just take that two books, and one of them, if you can do that per week, one session, that would be nice. Yeah. Mm.
Okay, sure, sure, Manoj. Yeah, thank you.
Okay.
Yeah,
Thank you
then we
then.
can post.
Yeah, yeah.
Bye bye.
Sudeep, any doubts you have, or can we close? Yeah, he's already leaving. Okay. Vinay, thank you so much. Okay. Satish,
Thanks,
thank
Vinay.
you. Yeah. Good night.
Yeah, bye.
Hello.
Yeah. Hi, Sudeep. Uh,
Thank you, Manoj.
yeah.
Good night.
Good
Good
night,
night,
Vinay.
everyone.
Yeah.
Getting
Sudeep, you have any doubts?
actually it will that expired now that
Yeah.
link.
If it
So
expires, no, you should rejoin immediately. That's all. Because
okay,
because
okay.
it expires, and then every 60 minutes it expires actually. Yeah.
ठीक है ठीक है.
Yeah,
Because
yeah.
I got the approach idea, so
Yeah.
let me go through once again. So next session maybe I can clarify certain things.
No problem. Yeah, fine, fine. Yeah. Any doubts, you
Okay.
can let us know. Thank you then. Bye. Good night. Yeah.
Okay.